Hey, so I want to write ls in Python today. I think it'll be a fun exercise. So ls is a pretty straightforward command, and I've got a few different modes here. I actually made a test directory so I could take a look at like different ways of requirements for ls as we're going to write it. We're going to write a simple version of it. It's not like the full-blown version. And if I go into the test directory, you can see I've got a few different things in here. I have directories with different permissions on them. I have Symlinks. I have regular file. I have a Symlink where the file that it's pointing to is missing. And these are just some of the test cases that I'm going to make sure that our Python ls is going to be able to handle. Yeah, so let's get started. So put in the shebang here. Oops. And so the requirements that I have for this ls, I think I want to be able to accept a directory parameter that will and default to the current directory. So this would be a positional parameter that just specifies what directory we're looking at. I want to be able to allow the -a flag to show all dot files, including dot and dot dot. I want to allow the -l flag to show the full, the long version of there'll be some caveats on that, but basically we're going to show what ls shows, and then I want to list. I want to sort the listing. Dot files first, then alpha sorted non-dot files, or regular files, and I want to be able to show Symlinks as well in long version. And you should be able to combine the flags too, right? So you should be able to say ls-la, directory, and get something that should work too. So I'm going to start with just a very basic version of ls. Let's just do the case where we're just saying ls. And so let's say, so we're going to use, let's see, we are going to use os.listdir. And I don't have, so I need arguments first, but we can do the current directory for now, just to get started. And we're going to just print the file name. So this os.listdir just gives back an array of file names. It's really simple. So I have to import os. And let's just run this. So I'm in tmux right now. That's the line at the bottom here. And I'm going to open up a new terminal so we can run our script. And I need to add execute permissions to my script. And then I should be able to run it. And was that correct? No, that didn't do anything. Okay, so I have this function, but I'm not actually calling it. So I need to put this in. If I'm running it from the command line, then I want to just run ls. And let's try it again. Great. So that's behaving as though we have passed in -a, but it's the basic version, right? We just have a list of files in the directory, and we're already going with just a few lines of code. Now, we're going to quickly want to be able to parse a bunch of arguments. So we're going to want to be able to accept arguments into the program, and actually Python has a pretty nice utility for this library called argparse. So we're going to use that. And what you do is you make a arg parser. And what's cool about this thing is that it'll actually give you free help. So it'll give you -h as long as you provide a little bit of a description. You'll get -h for free. And then you can add arguments that you want, both positional arguments and optional flags. And so we're going to add the -a now. And actually, let's do the directory first. So you want to be able to provide a directory, right? So you don't just want it to always be the current directory. So we're going to accept a string here. And we're going to allow 0 or 1 arguments, which is the question mark, the number of arguments. And the default is going to be the current directory. And then all we have to do is parser.parse args. And we get our args. It's a little dictionary that we get back of the arguments that were supplied. So we're going to do that. And let's see. So now that I've got the arguments, I can just do args.directory here. And that should list whatever directory name I pass in. So let's try it out. So add our arguments. Add argument, sorry. All right, so great. And can I try my test directory? Great. So I give my test directory, and I also get a list of files. So that looks like that's working. By the way, speaking of which, this test directory is a directory where I've just put a few different test cases in. And these are ones that I want to be able to display properly with my program. So I've got in here a directory that is set to executable only, but not readable. I've got one with no permissions where I can't read or execute on it. I've got one that's readable and it's just kind of like, but not executable. And then this test directory itself is one that's readable and executable. I also have a regular file here, which is a text file that says hi in it. And then I have a symlink to that file. And then I also have a symlink called missing symlink here that is pointing to a missing file. Yeah, so that's my test directory. I want to make sure that my program works on that directory. I'm not going to write any actual tests here. I mean, you know, if I were sort of doing LS for real, of course we would have a big test suite. But for the sake of time, I'm just going to write this and we'll test it on this directory. So cool. I've got, I can accept a directory name now, and that seems to be working properly. We can even try ... and that works. So now I want to be able to accept the all flag. And I want to make the distinction between all the dot files, you know, showing the dot files and not showing the dot files. So this is how you set up an optional argument in argparser. And include dot files in listing. And you can even see, so when I add this argument, you can see how the help function works. So if I run ls-pi -h, this has been automatically generated for me by the argparse library. It is just, and you can see we have the positional argument of the directory name, and then we have all or -a available. And right now that's not doing anything, but we can have it do something. The way to have it do something is by providing, well, we want to check on it. So if all, so now we need to kind of figure out which directories want to show. But if we're providing the all parameter, we definitely need to add, from where it is now, we need the dot and dot entries, the current directory and the parent directory entries. So I can add those. If I create So if I start by creating an array of, let's see, dirs os.listdir directory, I'm going to start by creating that array, and then I'm going to modify it based on whether we have this all parameter or not. So if all is there, I definitely want to add curder and parder. These are the Python names for the current and the parent directory. And if we don't get args.all, I actually want to remove things from dirs. I want to remove all the dot files because I don't want them to show when the -a flag is passed in. So let's just look at this and make sure, first of all, I want to make sure that this parameter is working properly. And it looks like we're not getting those entries. So what's going on there? So dirs plus dirs equals os.listdir if args.all, then dirs plus equals. So let's just take out that if just to debug this and see if that helps. So if I just do this, do I get it? Yes. Okay, so something's going on with my if statement there. And okay. Well, all right. Now it's working. Cool. Great. Wait. No, it's broken. Okay, so what is going on there? So parse the arg. I added this -all argument. That should work. Okay, I'm super confused about why this isn't working. So let me print out args. I'm going to do pretty print, and we can print it out. Port pprint, and let's print out args and see what's going on. Oh, that's right, you have to pass parameters to pretty print. All equals false. Okay, so, that's right, because I haven't, it is working. I haven't provided the -a, so I need to do that in order to see. That was kind of dumb. So ls.-pi-a, and oops, I got rid of the arg parser line that I wanted. We'll get rid of the pretty print. Okay, so now, great. So if I supply -a, I get the dot files, and the only problem is if I don't supply the -a, I still get this .ls.pi.swap file from Vim. So I want to actually have an else here, an else branch where I get rid of the ones that are dot files from the normal listing. And the way I'm going to do that is just with a simple list comprehension where we will go through and look to see if the first character is a dot. Pretty straightforward. And there we go. So now my standard one is giving me no dot files, and my -a gives me everything. And the next thing I want to do that I'm just noticing right away is I want to be able to sort the listing. And it would just be nice to have it be sorted because, well, that's a requirement. So let's try this. We're just going to sort the array with a regular Python sort. Looks pretty good. Actually, I think that's exactly how ls shows the lists as well. Yep. And we can also try it on our test directory just to make sure that like everything's in alphabetical order as well. Yep. Looks like it's in alphabetical order. Cool. So now I think it's a good moment to do some refactoring. So let's start by pulling this parser into its own function called parse args. And what this will do is it'll just return whatever it parsed. So it's just going to parse all the arguments in the command line and then return what we got back, this dictionary. And then I can call it, I'm actually going to call it down here. So I'm going to set args to that, and then I'm going to call ls and pass in the args to the ls function. So let's see if that still works. Looks pretty good. So now, what do we want to do next? So -a is working well. We've got this ls here. You know, there's an interesting thing going on where if I go into my test directory and I run my ls, and then I look at something that I can't look at, I get a crash, I get a trace back, and I get this nice, actually pretty nice OS error. And I was noticing this, this permission denied error is what ls would do as well, right? It would give you permission denied. I don't want the traceback to happen because I actually expect this error. So there's like a couple ways that you could approach this, right? I could have looked at this directory string that's being passed in from the argument, and I could have said, oh, well, let me make it so that that has to be a directory and like fail out of my program if it's not, or that it has to be, you know, one that I can access. And I looked into this, and you can do that, right? And here's a Stack Overflow article that that does that. And they bring in argparse, and then they set up this action. Actually, here it is. This action for argparse that goes through and checks that it's a directory and like is return all these, you know, all these raises exceptions when things aren't going well. And you know, I tried that, and it's cool, but it's kind of a lot of code. And what I thought we could do instead is just catch the error that's already happening. In other words, when we go in to do this lister, what we're doing is we're asking the operating system for a list of files. And if there's any problem with this argument, the operating system is already going to deal with those errors. And so just by having this in here, we're going to get the exceptions that we want when this parameter is not a proper directory. So if I do ls.py and I just give it a random name, I'm going to also get a traceback that says message file or directory. So I want to be able to show those things, but I don't want the traceback. So in my main, I'm just going to catch that. And I'm going to print it. And let's see what that looks like. Cool. So now I just get a simple, set of error messages. That's great. So let's head back to our program again. So I've pulled these things out. There's probably going to be another one here pretty soon that actually just does the printing part. And we'll separate that out, but we haven't gotten quite there yet because our printing right now is very simple. We're just going through each file and we're printing out the name of it. But when we start adding this long flag, we're going to start running into a need for a little bit more separation. So anyway, let's do that. So I'm going to add another argument to the parser, long flag. And the action on that one is also going to be store true. In other words, that just means that long will be false unless you, by default, and if you pass the -l flag, then it will be true. And this one is, just the help is show the longer detailed listing. So we can try our help again. Make sure that's showing up. Great. So now we need to be able to handle this -l. So, well, we can start out by saying if args.long, we're going to want to do, let's call it ls_long. And I'm just going to pass the args down into this ls_long because we're going to need to know what directory we're doing and stuff like that. Oh, wait, sorry. No, I don't want that there. So let's see. I'm going to move this whole thing outside of the for loop. And yeah, so args.long. And then this one, we'll put the for loop back in here, and this will be our short version. So this way we've extracted long out into its own function because it's going to be a little bit complicated. So this code is going to start getting a little longer. So now we have ls_long, and we accept args. And what is ls_long going to do? Well, it's definitely going to do the same thing that the short one does. It's going to go through our directories, but we don't have access to that right now. So it would be nice to actually pull out this functionality, because this does this takes care of the sort of, if you think of ls as like parse the parameters, filter the list of files by parameters, and then deal with output separately, we can separate those components out pretty nicely. So I think what we want to do here is make this its own function. We'll call that list_dir. And so I'm going to extract this whole thing into its own function. And we can have this actually take the args as well, because it's going to need to know, which directory to use and whether we're doing all or not. So great, and then we can actually just return the sorted list of files. Now this is nice because all of a sudden this just becomes, instead of dirs, this is list_dir args. And then thankfully we can use that here as well in our long listing. So if I just print, let's just see the long listing work, right? Let's make sure that our flag is working. So I'm just going to say long listing at the beginning, and then we will, oh, hey. So let's see. Oh, right. So I'm getting basically a none back from this list_dir function, and I don't want the none. I want the dirs array. And .sort unfortunately returns, it's just the way it's designed. It's not fortunate or unfortunate, but it returns an empty. It returns none because it's actually sorting the array in place. So I want to sort here, and then I want to return dirs. And this should work now. Let's see. Cool. So that's the long listing, and this is the non-long listing. And I should be able to use my A flag as well. So LA should show long listing with all the files. Okay, so what we need to do now is actually make the long listing be the long listing, right? So that's going to entail, first of all, getting a bunch more information about these files. We want to pull each part of this ls command, this -l command. So let's take a look at what those pieces are. The total at the top I'm not going to include in my version. We've got the permissions on the file here on the left, and this is, there's a file type over here, the first one, the first character, which is like directories or symlinks, special files, temp files. Then there's the owner's permissions, read, write, execute for the owner, read, write, execute for the group, in this case that's staff, and then read, write, execute for the world, for everyone on the system. And so we want all that information to be displayed nicely there. This is the inode number of the directory entry. This is the user and group who own the file. And this is the size in bytes. And then here's a timestamp. And the file name at the end. There's another thing we have when we look at this test folder. We also have a couple other things coming into play. The main one is that these missing symlinks, any symlink shows what the target is, the target file of the symlink. And it's nice because it's also relative to where we are now. It's the target file relative to the directory that we're LSing. Great. I think that's all we're going to need for the long listing. So what I'd love to do is just start gathering some of that information. So let's start with a mode. So this whole thing is the mode and permission structure, and it represents coming from it's actually like an operating system call that you make to get this information for a given file. And when you make that call, you get back a number. So let's take a look at we actually get back a bunch of data. It's the stats for the file. So we're going to let's just get some of those stats out and take a look at them. So we're going to run os.stat, and with the function passed in, and we'll just print out, I'm going to pretty print that. So what we have now is this stat result object, and it's got, it actually has all the information, well, almost all the information we're going to need, but it's in kind of this weird format. Everything's a number. This is like really old school, like 1970s stuff that hasn't really changed since then, and it's just being, it's coming directly from the operating system, from the POSIX standard operating system call to get the stats for a file, this information for a file. But what we're doing here is Python's kind of turned it into its own object. So at least we have that. And the one that we care about for generating this mode line is called stmode. And you can see these numbers. They're just numbers. And what they actually represent all this mode information. But what we have to do is we kind of have to take this number apart in order to see it. So the first thing we can do is let's pull this stats out into a variable. And we can print out, let's print fn.stmode. Oh, sorry, not that, file stats.stmode. And now we have those numbers again. These numbers start to make a little more sense when you convert them to octal. So now you can see there's some numbers at the beginning, and then these last three numbers, 755, 755, 644, these represent the permissions in octal format. And the way that works is they call it sort of traditionally in C a bit vector. And the bit vector format for file permissions is that if it's a 1 is execute, I believe. These are the protection bits. And a 1 is also, a 2 is write, and a 3 is read. And these protection bits are, they add up, right? So if you have read, write, and execute for, so if you have read, write, and execute for a given user, you've got a 7. And you can see the 7 right there. That's read, write, and execute for the user. And then the 5 and the 5 are for the group and the world. So you can see that matches up to this. It's 7 is read, write, execute on, this is for the entry dot, read, write, execute. And then 5 and 5 are the two read and execute options. So it's just adding those numbers together. And actually what ends up happening in here, we're going to want to take this apart into the binary in order to deal with it properly. So this is actually binary 1. This is 10. And this is, I'm sorry, I said 3, but I meant 4 here. So it's 1 plus 2 plus 4. And this is read, right? So we kind of keep going up, and if there were other protection bits, it could be 8 and so on. These are the basic ones. So we actually need to take these apart and take a look at them in order to generate the string of protection bits. So let's go back to our ls long. We've got our st mode, and we're printing that out. This is where we can, actually all we really care about is the last part of this. We're just going to do these characters right now, so we only care about those last 3 digits. And so I'm actually going to take the last 9 bits off of the end of the binary representation of this. So first of all, if I print this out as binary, you can see what that looks like. And in this one, these are the bits that I care about. And you can see this even now starts to map to this, right? So where there are 1s, we show the character, and where there are 0s, we show dashes. And it's pretty clearly mapping to it now. So we've taken this number apart, and these last 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, binary numbers, represent this these values. So let's take those first, those last 9 values and work with them. And of course, there's a lot of ways we could do this, but I'm just going to turn it into a string and slice it up. And now I want to go through, I also want to make an array that represents the possible characters that we're going to have in the mode view. Yeah, so let's start building up a string of this RWX piece, and then we're going to deal with the file type, the first character of that string later. So let's start with an empty string for the mode, and then we're going to enumerate our permissions string. This is now just the last, this last 9 characters of the binary representation of this thing. We're going to enumerate this string, and as we enumerate it, we will take a look to see if the value is 0, and if it is, we're going to add a dash because that one says no, it's not allowed in that permission. And if it's not a 0, we want to actually just add whatever character we're on. So the I, which character we're on in this array. I want to go to my mode characters, and I want to pull out I modulo 3, right? So that will pick whichever character is correct. And then let's just print the mode out at the end. Oops. Great. So does this look right? I think so. Yeah, that looks pretty good. So we've got the basis of this mode string in just a few lines of code. We are going to need to do the file type. So let's take a look at that. But what I'd love to do is yeah, we're going to pull all this out into its own function in a second. So I want to get the file type character for a given mode, right? So we have the same st mode number, and actually now the stat library gives us a nice some nice helper functions that let us get this value. And I'm just going to support a couple different things. I'm going to support directories, and I'm going to support symlinks. And if it's a symlink, I'm going to return an L, which is what ls gives us. And then otherwise, I'm going to return a dash. Now, this isn't a complete implementation of the file type character. There are other file types available, but this is all we're going to do for now. And those are actually, if you wanted to do the other file types, they're all available as part of these helper functions inside stat. And the other thing I need to do is import that stat module, which I don't think I'm going to use anywhere else, so I'm just going to import it right here. And now we can start with the mode being the file type char, and we can append to it, right? And we're going to pass the entire mode back into it to get that character. So let's see how that goes. All right, so module has no attribute isLink. Oh yeah, because it's not isLink, it's isLNK. Huh. Okay. So, all right, we've got, check it out. We got the first character, the type character. Looks like it's working well. We have directories, we have non-directory regular files. I want to look at my test directory to see how that goes. So I'm going to add test and see what we get. And uh-oh, we have no such file or directory executable. That's an interesting error, isn't it? So if I go into this directory and I run ls, do I still get that same error? No such file or directory, missing symlink. Okay, well, so I think we have two different bugs here. One of them is occurring when I don't pass in an argument and I'm doing an ls on a current directory and I have a missing symlink. So the symlink's target is a file that doesn't exist. And somehow in our program, we're trying to open a file that doesn't exist I think it's because we're trying to get the stats on it. So we've already run into that bug. And the other bug is that this no such file or directory executable. And that one happens only when I'm saying ls and from the parent directory and doing an ls of test from the outside. And I think the reason this is happening is because it's looking for a directory called, or a file called executable, and our current working directory for our script is the directory we're in right now, not the test directory. So we need to actually tell Python to look in the test directory for executable in order to have this work right. So in other words, where we're doing the stat initially, we're going to need to do, we're going to need to actually add the directory name to the, and join it to the file name of the file that we're getting the stats on. So that should fix the executable bug. Let's take a look. Oops. So what do I have wrong here? I think os.file.join is probably not the right thing. This is, let's see, what do I want here? It's path.join. That's what it is. Okay, so os.path.join. Great, so now actually it's working. It's getting the one for executable, and at least we have the same error message where the missing symlink is coming up. So there's a reason for this, which is that when you run stat normally, it tries to actually follow the symlinks and stat whatever's at the other end of it, right? But for the purpose of ls, we actually want to get the stats on the symlink itself. So there's an alternative version of it called lstat. And lstat actually gets the stats of the links and not of the files behind them. And when you change it to lstat, there we go. Now we have all of the files in the directory. Looks like we also have the L flag for symlinks, and that's working properly as well. Great, so we have two, well, we almost have two of the fields here. We have the permissions field and we have the file name. Now we're going to have to add the symlink target to the file name, but we'll do that a little later. Now, there is one thing that's missing, and if I go and do an ls on my root directory of my computer, you can see this last column with the @ and the plus. We're not going to use that. I think it may be Mac OS specific. I'm not sure. I'm not even sure what the @ means. So we're not going to use that. We're also not going to implement the other mode flags that can be possible here. We're just going to implement the basic ones. All right. So back to our program. The next thing we need, we have this column right here. We need to get the inode number next. And that's going to be pretty straightforward. I'm going to take a second. I'm going to start building a directory entry. So an entry would be like an array of all of the different values in this long format. So instead of just grabbing all these things at a time, we're going to put it into an array. And what this will have in it is entry equals mode and file name. And then we can pprint the entry. Cool. And then we're going to keep adding to this array. So what's the inode number? The inode number we can get by calling stnlink. That's the number of, great, okay. And that looks like that's exactly what we would expect to see. Yep. Now we're going to add the owner and the group. Now this one's tricky because what you get from file stats, if we go back and just print out the file stats, actually I'll just put it in here. Oops. Can't pass two parameters to pprint. So we have the user ID and the group ID, but they're numbers. And so we need to convert these two numbers, user ID and group ID, into the actual name of the user and the name of the group. And there's another OS utility for this that's called, let's see, it's pwd. From pwd import get pwuid. Get pwuid, and then and this is actually going to, this is like one of those other classic Unix things where it's going into the password file, etc password, and the etc group file, and it's looking up the names of the password of the users and the groups from those two files on the system. That's at least what it purports to do. On Mac OS X, I'm not even sure if we have an etc password file, so let's take a look. No. So those don't exist on OS X, but you still do use the same code to get back that information from Mac. You know, the Mac has its own database of users and groups. And this is a Python way of querying that database. So we're going to query that, and we're going to pull instead of, and we're going to actually run that on this get pwuid on the file stats dot st uid. So let's take a look at what we get back then. Oops, I want to print out my entry now. Okay, so now we're getting back this whole object from the password file or the password dictionary directory, and it's got we actually just want the name of the user. We don't care about all this other stuff. So great. Let's do that and just pull out pw name. Cool. All right, and here we go again. We're going to get the group ID and the group name out of the group name, the group name database. So it's very similar. It's just gr instead of pw, and then we're passing in the group ID. Yay. All right. So the next thing we need is the size of the file. Turns out that's really easy. If we go back up, the st size field is the only thing we need. It's just that. I'm turning these all into strings for a reason that you'll see in a minute. File stats.st size. Cool. And let's take a look at that. Make sure it's displaying properly. Great. All right, we're starting to see something. And somewhere in here, we're going to need the time as well. And stm time is the field that we want, but right now it's just a big number. This is the number of seconds. This is epic seconds, number of seconds since January 1969 or something like that. And we want to convert that into a nice looking date. We'll do that in a minute. Great. So I would love to pull out some of this functionality now that we just have the basic pieces into a little bit more of a concise set of functions that separate out the functionality. So, for example, we'll have a function called long entry, and we're going to provide the path and the file name to this, and this is going to return the array that we're starting to build up here. So long entry will take this stuff, move it into here, and I'm moving the file stats piece into here. We're going to pull the file stats, and instead of args.directory, we have the path now. And the other thing I want long entry to do is to just return this array, this entry array. And we'll get that working properly. It's not going to work initially right now, but we'll get it working properly in a second. Yeah, so our code is broken now. But we pulled out the basic functionality of getting a single long entry into this function. And now I think the next thing we want to do is calculate the mode string in its own function. So let's pull all of this stuff out into a function that we can call formatted mode. And it's going to receive the st mode from the stats. That's the only thing that it needs. And it's going to return this mode string. And it, in turn, is calling this file type char function. And now we can use formatted mode up here. And filestats.stmode is what we're passing into it. So great. So now we have a function that returns the long entry. And what I want to do now is call that here. And now our ls long is much simpler. And this is args.directory and fn. So let's just do this. We'll get the entry and we'll print it out and see if our code is still working. Hey, looks great. And our functions are getting shorter. They're getting more readable. I think we're ready to move on to the next step. So let's see. We need to deal with the time. The time is a number right now, and we actually want this to be formatted. So we're going to make another function called formatted time. And we'll pass in the modification time to it. And that's going to return the nice string of the formatted time. And it's taking the modification time. And how do we format this? So, so first of all, I think we just want to return a very simple, we're just going to use strf time, right? So for simplicity, I'm going to call this dt. And we want to do strf time of it. And this is a format for strf time that looks like the one in ls. And this isn't going to work first because this st size is actually not a, this stm time is not a date yet. So I don't think that will work. What we actually have to do is convert it into a proper date. So that's fine. I will take it and do that in here. So what I need to do is datetime.datetime.from timestamp and pass in the stm time. And we'll set dt to that. Okay, global date time is not defined. Yeah, so we need to import date time now. Cool. So that's the basic version of the time string. Now, there is one issue here, which is that we actually have to account for the year as well. So if I do a long listing of my, oh, well, that doesn't have any examples in it. If I do a long listing of my applications directory, you can see that some of these have years in them and some of them have just the dates and the times. So that's a nice, yeah, so that's something that we definitely want to, we want to make this possible where it's got the year on it as well. So all right, let's do that. And the way we're going to do that is we want to just check to see if the DT object is more than a year ago. So it's now minus, and we're going to use time delta to say days equals 365. And if it is longer than 365 days ago, we want a different strf time for that. And this is where we put the year in instead of the hour and minute. So let's see if that's working. And do we have an example? So there's one, 2014. We have a little bit of a problem here. We want the width of the time strings to always be the same. And we're going to deal with widths more thoroughly in a minute. But just to get this one going, the way ls does it is they put an extra space before the year. So let's do that. Great. So now our time strings are all exactly the same width. That's going to help us out later. So what's our next thing? Well, we want to take this entry that we have and this long entry, and we want to actually print it out in a real way. So instead of printing the array, we actually want to print just to print a line. And a simple way to do this would just be to join it and print that out. Let's try that. Oh, and we want to separate it by each field by a space. And let's do, oops, -L. Okay, so we're really close at this point. We just have one little problem, which is that we've got all of these fields, and we want to pad them on the left side, especially these fields, this size field, which can be vastly different. And we want to pad them only by the amount of characters that are necessary for the longest width, right? So if the longest width of the size field is 5 characters long, then we want the whole thing, the whole column, to be 5 characters long. So this is going to be a little bit of a manipulation of each of these fields. We're going to go through each of the entries at the very end when we want to figure out the maximum width. And then with that maximum width, we want to actually pad every entry so that it fits to that width. We want to use like justify every entry. Yeah, so that's an operation that's going to happen after we get this entry back and before we print it out. Yeah, so in this ls_long, we want to actually build up an array of entries, and then we're going to use that array of entries to go back through it for a post-processing step where we figure out the right size of each column. So we're going to start with an empty array of entries, and we're going to start appending to it each long entry. And then what I want to do is take this and format and print the long entries. And I'm just going to send it into a new function because I know this is going to be a bit of work. And this function is just going to take the entries array and do that for us. So let's do it. So we need to start by determining the column widths, right? So I want to know the widths for the maximum widths for every column. So the way we can do that is start with column widths is an empty array, and we're just going to go through all the entries rage. We're going to go through the first, so we've got an array of arrays, this entries, and we want to go through the first one and look at go through the number of fields, right? This is just saying, give me a range that goes through all of the number of fields that are available. 1, 2, 3, 4, 5, 6, 7 fields in entries. And I actually don't want to go through all 7. I only want to go through the first 6. So it's fields -1, because the 7th one, the very last field, which is the file name, I don't want to add spaces on the left side of this. I just want one space in here. So I'm going to go through all the fields except the last one and figure out what the lengths are, the column widths. And we're going to do a little list comprehension here where we grab a column out of our nested array, and then we can actually call max on that. Okay, so what is this doing? It's getting the maximum length column. It's getting the maximum length entry out of the column that we've created, and then it's getting the length of that entry. And then it's appending that to each column widths. So the column widths array is now, well, let's print it out. It should show us the maximum width for each entry. Yeah, so it's saying that the permissions field is maximum 10, and then this number is maximum 1, and then 8, and that looks correct. 5 for staff, size, and so on. Great, so we have these column widths now, and I think we just want to, actually, I think this can become its own function, right? So this can be one we can call determine column widths. Right? Because we can now just return this array of column widths back. And that keeps our function nice and small. Great, so the first thing that format and print long entries is going to do is determine the column widths. And now with those column widths, we want to go through each entry. And we want to create a new formatted version of the entry. So we're going to start by just joining the entry. But instead of joining the entry itself, the entry array itself, we actually want to, we're going to do a little voodoo magic in here and do a list comprehension on the entries that helps us justify. So we'll have something here. And we're going to go through entry, enumerate it, and then we'll have something here that uses the column widths and actually justifies each string, each S in the entry. So what this is going to look like is rjust, and since we have the index from our enumeration, we can just use column widths I, right? Let's take a look at what that looks like. Integer index out of range. So the reason that's happening is that we enumerated the entire entry, which includes that last field that we don't have a column width for, the file name, because we did this -1 below. So I'm now going to just get everything but the last one. And that seems to be working. Does it actually do anything? Well, we can print it out. In fact, that's what this should do because our function is designed to print. Wow. So there we have the really basic output of ls without the file names. The only thing we need is the file names added to this. So that's fine. We can just add the last entry to the array before we put it together. And there's the file names. So now I think there's only one more thing left to do here, which is we haven't addressed these symlinks, right? So the difference between ls.py-l on test and ls-l on test is, well, the colorization, which we're not going to do today, and the pointers to the symlinks. We want to actually see what's the target of each of these symlinks. I think that's the only thing we have left to do here. So let's go back and add that in. So in our entry that we're building, the long entry, we have this file name here, but we're actually going to need to now make another formatter, right? We're going to make a formatter for the file name. And if the file is not a symlink, then we can just return the file itself, right? And if it is a symlink, then we're going to deal with that case. Now, what we need to pass into this is the, remember that mode, st mode? We have to pass that in here in order to check whether it's a symlink or not. And so I can't just pass the file name. I also need to pass filestats.st mode and accept that in as the mode. So if it's not a symlink, we can return that. If it is a symlink, we want to get the target of the link. And the way we can do that is with os.readLink. And all it returns is a string with the target of the symlink. And we're going to pass in the file name. And then what we can return here once we have the target is the file name itself, and then that little arrow and the symlink target. All right, let's see what happens. Okay, so global names not defined. Okay, so I actually pulled this, I only used the stat module in this one area, but now I'm using it in a couple places, so I'm going to import it globally. Okay, so now we have this weird error again, which is missing symlink once more. I think what's going on here is that the symlink, the readlink function, actually does need the full path name passed into it in the same way that the lstat function needs the full path name passed in. So we actually have to do os.path.join again and pass in the path and the file name. And we need the path passed into this function as well. And yeah, so let's pass that in. And there we go. Now we have every piece of ls. We've got the symlinks showing, we've got the size of the file, we've got all kinds of stuff. So we can try it again on our root directory, see if that works. That looks pretty good. Yeah, so that's all. That's ls. One more test we can do is make sure that -la is working properly. So -la shows me all of these dot files, and yeah, that looks pretty good. All right, thanks for coming.